Cheers, Chris. Hi, I'm Elliot Brett. I'm a CG artist at Jaguar Dizájn Visualization team. Basically what we do is we take the alias model from Chris and the team and we turn it into photorealistic still images, animations, virtual reality, that sort of thing. So I'm just going to show you a little bit about what we do as a team.
Okay, so the first part of the process, once we've received the data from Chris, is to tessellate the NURBS data into polygon data. So Alias works with NURBS surfacing. NURBS are primarily composed of four-sided surfaces, but once tessellated into polygons, these turn to smaller three-sided shapes. In our team, we use a program called VRED for this. This process of tessellation from NURBS to polygons allows for a better workflow in rendering software, such as the one I'm going to show you today. It's called Maya. We use Maya in our process when we require the most photorealistic still images or animations, but we can also use VRED when we need to create quick renders in predefined views and lighting setups for design reviews. We also use this software for real-time reviews and virtual reality. So this is what Maya looks like. Along with Maya, we use a render engine called V-Ray. V-Ray is a plugin for Maya which allows for very realistic shaders, in particular, very realistic car paints. So once we have the car into Maya, then we start to apply the correct materials to the correct parts of the car. We work very closely with the designers and colour and materials team for this, and can manually build textures and paints to their specification, or we also have the option to scan paints and fabrics using a highly detailed material scanner. So I'm now in the IPR, or the Interactive Production Render window inside of V-Ray, to check the materials and the paints are correct. We have photographed a 360 HDRI, or high dynamic range image, of our new Jaguar Design Studio in Gaydon, England. This allows us to see the car in a familiar place with familiar lighting, and we have the ability to compare the digital paint sample with a physical one. We want to make sure that we spend a good amount of time getting the materials correct, as it's very important to get the car looking as realistic as possible. We also want to make sure we capture the design intent correctly, and particularly in these times when we don't have the ability to see the actual car paint. The digital model and its colour material application needs to be very accurate. In addition to paints and metallic finishes, we also look at glass shaders and levels of tint. Once the exterior is complete, then move on into the interior and spend a large proportion of the time on the interior surfaces and following basically the same process. So now we turn the IPR window back on and we have a good look over the car and the materials, checking that everything is as it should be, zooming into areas and checking that they have the correct breakups. We also will check the glass has the correct refraction properties so that you're seeing through it as expected in real life. So I also look into the paint shaders and make sure that the metallic flake is to the correct scale. Some paints don't have the metallic flake, so we don't need to worry about that sometimes, but for this paint we do. All of these things are very important to get a realistic and accurate representation of the real car, and can be used for parts of the design process where a real car doesn't exist yet. So it's very crucial that it's represented correctly. So now that I'm happy with the way that the car and the materials look in this Studio HDRI, I'm going to move it into an environment where we can really sell the design idea and meet the brief for how we want to show this car virtually. When setting out or planning an animation, we will normally start with the brief, and then we draw up a 2D storyboard, a mood board, or a quick 3D animatic to get across our interpretation of the brief. The brief for this car's animation is to show it in a clean white space, which has a hint of a gallery, to show the car as a piece of sculpture or art. For this animation, I've actually switched to a production dataset. We always try to get as detailed 3D models as possible to help us create the most realistic looking outcome. Once we have agreement on the storyboard, we will start creating our environment or scenery, and for this there are two main ways in which we go about it. The first is to build the geometry and texture it as realistically as possible, usually using photo references to get the right textures and the right proportions to all of the geometry. You can model basic and complex geometry in Maya, and even import models and assets from other scenes. You can then texture the scenery in exactly the same way as I did for the car. The second option would be to film a space and then drop the digital car into it. This would then require capturing of another HDRI, similar to what we had earlier in the design studio, and potentially need to track camera movements into 3D space to ensure that the car sits in the scene. This is quite complex, so for today I'm going to show you the first option. For this gallery space, we've modelled walls, some plinths and benches, included a wall-mounted leaper, and created a low wire barrier around the car. We've also created a lighting rig to sit above the car, which will add to the detail of the scene, but will also be where we position our digital light sources. We try and add as much detail into the scene as we can and focus it around the areas where the cameras will be pointing. So now that I've imported the car into the scene, the next step is to light it. I'm using a series of cone lights in this scene to act as spotlights coming from the ceiling, and some other additional lights positioned around the car to best show off the shape and form. I'm just going to get the IPR up again, and as you can see, when I switch the lights on and off, you can see how each light affects the car in different ways and adds different depth to the image. Once we've lit the scene, and we've got the car looking how we want it, we may need to come in and tweak some of the colours and the materials to work within this environment. What works in one environment won't necessarily work or look the same in another, particularly when doing an outdoor scene with the changing light throughout the day. A lot of time and effort is required to get the scene looking as believable as this, but the more time you can put into detailing and texturing your environment, the more realistic your outcome will be. Now that I'm happy with the lighting, I can move to the next stage, which is animating cameras and geometry. This can be done in many ways, creating complex rigging systems and locators for moving specific parts of geometry or cameras, or more simply by using keyframes at the start and end points of where you want the asset to move to and from, and then tweaking the speed of the movement on the timeline or in the animation curve editor. Rigging an animation can be an extremely involved process that can take years to learn correctly, and we have members of our team who specialise in either one or the other of these disciplines. Now that I'm happy with all of the elements in this scene, I'm now ready to render it. This can be a back and forth process with lots of test renders before you get to the final output to make sure you're happy with the final look and feel. So rendering an animation is quite a lengthy process, so we tend to render at 25 frames a second. So for every 1 second of footage, we have 25 images that we need to render. So one method in which we use to get renders back quickly is to render every 50th or 100th frame in the sequence, or when an environment changes, if you have multiple environments in your storyboard. When rendering an output, we will break down the render into a number of render passes. These are elements such as global illumination, ambient occlusion, specular, diffuse, depth of field, reflection, material IDs or masks. So the list goes on and on and on. This allows for much more control in the final output, and we can go in and we can tweak anything that we might not be happy with, or maybe a designer comes in and says, we want to boost the reflection on this chrome strip here, or we want to take reflections out of this chrome strip here. We can do that all in post. We don't have to re-render anything. Once we have these render passes back, we can start to composite them together and add any post effects. For this process, we tend to use After Effects, but there are many other compositing programs on the market. After Effects works in a similar way to using layers, as Matt showed in his Photoshop process in this series. In this compositing stage, I can also add in additional post effects such as glows, lens flares, and adjust depths of fields and apply film grades or LUTs, that sort of thing. So in this final stage, we can really play around with the look and the feel of it. We can add grades, and we can really start to lean on the cinematography of the animation.
that's a basic overview of the design visualization process. We do stuff like this for high-end stills, for PR release, such as the Gran Turismo animation. We do them for design reviews as well. But we also do a lot of VR, virtual reality, for interiors, so the designers can actually sit in their cars without the need for an expensive physical model. We exist in the design structure from as soon as there's a 3D asset that we can use all the way to the end when the car's being released. So yeah, I hope you enjoyed. Thanks a lot.